This is a video on Chapter 1, the first lesson, Relations and Functions. It's actually going to be split into two videos, one covering relations, functions, domain, and range, another covering all these things. But essentially, a relation is a connection from one set of data to another, how to move from the inputs to the outputs. You can do number of burritos to cost, move from age to height, player to points scored. It's basically the independent variable to the dependent variable, or the x's to the y's. We can show relations in a lot of ways. Kind of the most basic one, the one you see the least probably, is a mapping. Basically, this circle here contains all the inputs, or all the x values. This circle here contains all the outputs, or all the y values. And I can map 1 to 12, 2 to 20, -3 to 6, 5 to 4, and 0 to 4. All of these x points we call the domain. All of these y points we call the range. The domain is the collection of all the inputs, and the range is the collection of all the outputs. And a relation is just some way that we move from the inputs to the outputs. I mean, I could say like this is player number and points scored. So player 1 scored 12 points, and player 2 scored 20 points, and player -3 scored 6 points. But in some way, we're moving from one set of data to another. We actually show relations four ways: with a mapping, which I have here, a table, so here's the point -2, 6, and -2, 6, or a graph, because this is the point -2, 6. So each of these individual pairs can map to a table, which we can show with the graph. And we can also use an equation, and actually most of what we do is with equations. But this mapping that I set up here doesn't have any sort of formal equation to get from one number to another. It's worth noting that each of these points we call an ordered pair. It's basically showing, like -2, 6, it's basically showing what the input was and what the output was, or what your x value was and what your y value was. There's a special type of relation that we call a function. If every member of the domain, if all the inputs go to only one output, the relation is called a function. So here, all the members of the domain of the inputs point to only one member of the outputs of the range. 5 to 21, 8 to 0, 2 to 21, etc. It doesn't matter that 5 and 2 both pointed to 21. That's not an issue. The issue would be if 5 pointed to 21 and 5 pointed to 0. If 5 goes to two different things, we say it's not a function. So this is an example of a relation that isn't a function because 16 goes to 9 and 16 goes to 5. Since one input is going to two different outputs, it's not a function, but we can still call it a relation. And pretty much everything we'll do in this class for the next several chapters and several months will be functions. Here's an example of a function that doesn't have a rule, meaning there's no equation that I could write. But here's students with their names, and here's the scores they got on a test. We'll say it's out of 50, so poor Greg didn't do too well. But Amy got a 33, Bob got a 45, Chris got a 12, etc., etc., etc. We can give each of these students, instead of a name, a number. Amy is student 1, Bob is student 2, Chris is student 3, and now we have a way to map the set of students to the set of their scores. If I show that with a graph, student 1 got a 33, student 2 got a 45, student 3 got a 12, and you can see all their scores. Now this right now is a function because every student can only get one score. But suppose that Greg here got a score of both 2, and then let's say that Greg also got a 13 on the same test. Well, that doesn't make any sense that he can get a 2 and a 13 on the same test, because he just took the test once, we're going to assume. So this is not a function at this point because 7 is going to 2 and 7 is going to 13. And literally, it's not functional, like it doesn't work. Greg can't both score 2 and score 13 on the same test. We talked about how each individual pairing is called an ordered pair. Whenever you see a table, it's really listing points. These are all the inputs, we call it the domain. These are all the outputs, we call it the range. So right now the domain of this graph, or I'm sorry, of this function or table or relation would be 2, 3, 4, 5, 8, 12, and 22. The range of this relation, which is a function because each input goes to only one output, is -1, 2, -6, 30, 0, -1 again, and 2. And if I was going to list that, I want to do it in numeric order without any repeating numbers. So it would actually go -6, -1, 0, 2, 30. There's the range. The way it's listed right now, the numbers aren't kind of in any order where they match. Like this isn't saying that 2 goes to 6 and 3 goes to -1. They're just listed. There's the domain, and there's the range. So we say that a function is a relation where each input goes to exactly one output. Pause the video at this point and see if these are actually functions. Just take a moment and pause it and look it over, and then in just a second I'm going to go over them. Here, 5 is going to 2, and 5 is going to 4. So this is not a function. Here, 5 is going to 2, and 5 is going to 2 again. 5 can go to 2 twice. There's no reason that student 5 couldn't get a 2 on this test and do it again, or I mean, just have it listed twice, just list the same thing twice. So this is a function. 1 goes to 5, 2 to -10, 0 to 0, 1 to 5, 2 to 2. Here, 2 to 2 and 2 to -10 means this is not a function. 1 goes to 6, -5 goes to 6, -3 goes to 6, 8 goes to 6, 2 goes to 6. It's okay if everything goes to 6. That doesn't matter. Just the fact that each input has only one output means that this is a function. We have what's called the vertical line test. It's a way to check to see if a graph or if a relation is a function. So here I draw a vertical line, and I can take it and run it over the graph. And if at any point this line hits the graph more than once, it's not a function. So here I just hit that point once, and I just hit that point once, but I'm hitting this point here twice. 5 is going to 2 and to 4, 5 to 2 and 5 to 4. Since it's failing the vertical line test, this graph is not a function. However, over here, I've got a more connected continuous graph, and at every single point we're only hitting the graph, the vertical line is only hitting the graph once. Even here it's hitting the graph, way up here, but it still only happens once. Now you might want to argue that here it's happening a bunch of times because it kind of looks like that little section is going vertically, but it wasn't really meant to. So we're going to say that this is a function because it's passing the vertical line test. So you can take a table and if you want, graph it, or take a function and graph it, and look at the vertical line test to see if the table or the graph of the function, or the rule is a function, excuse me. So to recap, a relation is how we move from one set of data to another. Relations can be shown with mappings, tables, graphs, or equations. Each of these things represents the same relation, though. You can have a mapping, a table, a graph, and an equation that all covers the same relation, how to get from the inputs to the outputs. The domain is all the inputs, the range is all the outputs, and most importantly, if a relation sends each input to exactly one output, the relation is called a function. Thank you.